Hello and welcome back to G Fun Facts Online, your go-to spot for the most fascinating insights our universe has to offer. Today, we're looking up, way up, into Earth's orbit, but we're not just stargazing. We're talking about a growing problem that's invisible to the naked eye, but poses a huge threat to our future in space. Space debris, that's right, space junk. So how bad is it? Well, picture a cosmic junkyard circling our planet. We're talking defunct satellites, spent rocket stages, and tiny fragments from collisions and explosions. The European Space Agency, or ESA, is currently tracking over 40,000 objects larger than 10 centimeters. But get this, there are tens of millions of smaller, untrackable pieces zipping around. And when I say zipping, I mean it. These things travel at speeds up to 28,000 kilometers per hour. At that speed, even a tiny paint fleck can cause catastrophic damage to operational satellites, or even the International Space Station. In fact, the ISS regularly has to perform avoidance maneuvers. And it's not just the ISS. In the first half of 2024 alone, SpaceX's Starlink satellites had to dodge potential collisions nearly 50,000 times. This orbital overcrowding isn't just risky. It could lead to something called the Kessler syndrome, a nightmarish scenario where collisions create more debris, leading to more collisions, until certain orbits become completely unusable. Scary stuff, right? But don't worry, it's not all doom and gloom. Brilliant minds around the world are working on solutions, specifically active debris removal, or ADR technologies. This is where science fiction starts to become science fact. First up, we have capture mechanisms. Think robotic arms and claws. ESA's Clear Space One mission, for example, plans to use robotic arms to grab a defunct ESA satellite and guide it to burn up in the atmosphere. Then there are harpoon and net systems. Airbus has tested harpoons that can spear larger pieces of debris, while missions like Remove Debris have shown that nets can envelop and trap objects. And for metallic junk, some companies like Astroscale are pioneering magnetic capture, using powerful magnets to latch onto debris, as demonstrated in their ELSA-D mission. It's like a cosmic cleanup crew with some seriously cool tools. Beyond just grabbing stuff, we also need ways to move it. That's where propulsion and deorbiting techniques come in. One futuristic idea is laser ablation. Imagine ground-based or even space-based lasers gently nudging debris by heating its surface, creating a tiny bit of thrust. Over time, this changes its trajectory, causing it to eventually burn up in Earth's atmosphere. We also have space tugs, specialized spacecraft that can attach to debris and use their own engines to either push it into a safe disposal orbit or guide it for a controlled atmospheric reentry. And there are even inflatable braking devices, or IBDs. Attach one of these to a piece of debris, it inflates, increases atmospheric drag, and helps the junk fall out of orbit faster. NASA is also working on its own active debris removal vehicle concept, designed to capture and deorbit large debris from low Earth orbit. Now, cleaning up is crucial, but we also need to stop making such a mess in the first place. This is where orbital sustainability comes in, and it's a multifaceted approach. First, there are debris mitigation measures. Future satellites are increasingly being designed for demise, meaning they're built to burn up completely when they re-enter the atmosphere. Standardized interfaces, like something called MICE being tested by ESA, could also make future removal missions way easier. Satellites also need to have clear end-of-life plans. This means having enough fuel to deorbit themselves or move to a graveyard orbit, far away from busy operational altitudes. And it sounds obvious, but we need to prevent the intentional release of things like lens caps or protective covers during missions. Next, we need better space traffic management and tracking. We need to get better at spotting and tracking even smaller debris pieces. Systems like the U.S. Space Force's Space Fence are designed to massively increase the number of objects we can keep an eye on. With accurate tracking, satellite operators can predict potential collisions and steer their active satellites to safety. Automation and clear communication protocols are key here. Then there's in-orbit servicing and manufacturing, or ISAM. Think of it as roadside assistance, but for space. Technologies that allow us to refuel, repair, and upgrade satellites while they're still in orbit can extend their operational lives. This means fewer dead satellites becoming debris. Companies like Northrop Grumman are already developing mission extension vehicles. And let's not forget reusable launch vehicles. Pioneers like SpaceX and Blue Origin are making rockets that can be used again and again, which means fewer discarded rocket stages left floating around. Of course, space debris is a global problem, so we need global cooperation and regulation. Organizations like the United Nations Office for Outer Space Affairs and the Interagency Space Debris Coordination Committee are working on international guidelines. We're seeing some positive initiatives too, like ESA's Zero Debris approach, which aims for no net new debris from its missions by 2030. ISRO in India has similar goals, and the FCC in the US is also looking to update its rules. One tricky aspect is that some ADR technologies could potentially be seen as space weapons. So open dialogue and transparency are super important to build trust and avoid any geopolitical drama. Despite all these amazing technological advancements, there are still big challenges. ADR missions are incredibly expensive, and capturing uncooperative, tumbling objects in the vacuum of space is technically very complex. Plus, there are unresolved political and legal issues, like who's responsible for removing debris and the potential misuse of these technologies. The future of our orbital environment really depends on continued investment in these cleanup technologies, strong international teamwork, and everyone in the space community adopting responsible practices. Initiatives like NASA's Space Sustainability Strategy and ESA's Clean Space Program are paving the way. By taking proactive measures now, we can work together to ensure that Earth's orbit remains a safe and accessible resource for generations to come. It's a big job, but a crucial one if we want to keep exploring and benefiting from space. That's all the time we have for today on Fun Facts Online. I hope you found this dive into the world of space debris and orbital sustainability as fascinating as I did. Join us next time for more amazing facts and discoveries. Until then, keep looking up and keep wondering.